We'll learn.
Good afternoon. Today I'm going to be discussing the relationship between neonatal hormone exposure, later hormone exposure, and adult sexual partner preferences in rats. To start, we want to ask, why is this an interesting question? And we're all HEB, or most of us are HEB concentrators, so does this make sense from an evolutionary perspective? No. Arian's shaking his head. So we want to know why this is present, this behavior of pairing up with a member of your own gender is present in 3 to 10% of the population. Just out of curiosity, does anyone recognize the couples? They're the plaintiffs in the Proposition 8 case in California. And I think that also speaks to, as scientists, we do have a bearing on a lot of these public debates. So this research has more implications than just scientific curiosity. Now, there are 2 ways to study this issue of partner preference, sexual orientation. One is population studies in humans, and the other is doing some kind of nasty experiments on rats. I'm going to be talking about the latter. The paper I'm presenting is Hormonal Regulation of Adult Partner Preference Behavior in Neonatally ATD-Treated Male Rats. It was published almost 20 years ago in Behavioral Neuroscience. Before we begin, I know this is a boring slide, but we need to do some terminology. ATD is an aromatase inhibitor. That means it blocks the breakdown of testosterone to estrogen. Some of you will have heard of that because it's a breast cancer drug. It's what we use to prevent tumors from growing. DHT, everyone should remember from the textbook, is dihydrotestosterone, a very, very potent androgen. And E2 is estradiol, an estrogen. Okay? This is the terminology used in the paper. It's what's on the graphs. So there you go. Hypothesis. Prior studies had shown that ATD has an impact on behavior in male rats, except that they still had their testes. So this study wants to look at what happens if you control for the effects of testicular hormones, which means that you have to castrate the rats. Fun, right? All right. Test subjects. Male Wistar albino rats. They're kind of cute. There are 37 in the experimental group and 14 controls. Stage 1 of treatment. Between 3 and 9 hours after birth, the rats were given a celastic implant. The experimental rats were given ATD, and the controls were given cholesterol. This was removed when they reached the age of 3 weeks, which is about when rats begin to enter puberty. Over the course of their puberty period, the rats were given partner preference testing. So this is used throughout the study. It's very simple. There's a box. The experimental rat is placed in it, and then has access either to a sexually active male or an estrus female. And the researchers record how much time the experimental rat spends with either and what types of behavior it exhibits. Now, what you get is both the controls and ATD males prefer males, but the ATD males, prefer females, excuse me. But the ATD males, in the presence of males, will actually act as if they're estrus females, which involves presenting their genitals, wiggling their ears, and going into lordosis, the arch position that allows a male to mount them. After this, once they're through puberty, you castrate the rats, and you do more partner preference testing. Here are the results. On this graph, and all the graphs in this study, the x-axis is the age of the rats in weeks. On the y-axis, positive values show preference for females, negative values show preference for males. Okay? Before castration, you see that both groups prefer females, but there's a pretty large difference between the controls in white and the ATD males in black. Castration, afterwards you still have the effect, but notice it's in decline. And after enough weeks, they basically show no interest in either gender. After that period, the rats were divided up into 2 groups. Group A received 5 weeks of DHT, and then 3 weeks of DHT plus estradiol. Group B received estradiol for 3 weeks, and then DHT and estradiol for 5 weeks. Group A results. We just saw this part of the graph, and it goes up to about here. DHT is added here, And this is effectively statistical noise. There's no statistically significant relationship going either way. And what's interesting is when you add estradiol, you get very, very strong preferences for the female. And while there is a difference between the two groups, it's still, historically a strong relationship. Group B is a lot more interesting. Again, we already saw this part of the graph. Here's where estradiol is added. And this is the big result, that the ATD males show a very strong preference for males once estradiol has been introduced. Then, when you add DHT, that preference goes away. So just to make this visually easier to follow, if DHT is first, ATD and control males prefer females. If estradiol is first, the ATD males prefer males, and then when DHT is added, that preference goes away. I think this is a pretty obvious limitation on the study. Rats' partner preferences does not exactly correspond to our ideas about sexual orientation, partner preference in humans, pair bonding, that type of thing. What it does tell us, though, is what might be driving sexual attraction, that kind of first stage of interest in the person of your preferred sex. I want to return to the question of evolutionary explanations for why this might be. This is a standard helper at the nest model, right? So you have a father, mother, children, and one can conceive of having an aunt or uncle present who might help raise the child if they don't have children of their own. Now, I don't know of any strong evidence that this is true or not true. It may be, it may be not. It seems like a plausible explanation because we do see it in other species, especially birds. And one could see through a kin selection perspective how this might work. Again, homosexual orientation is present in 3 to 10% of humans. That's rather prevalent to just be kind of a fluke of evolution. So, the implications of this study. At its most basic level, the study shows that rats, when treated with ATD and then estradiol, have a certain preference for males. Okay? So it suggests that neonatal hormones, in addition to later hormones, testosterone or estrogen, will drive partner preference. So what this suggests is that in humans, neonatal hormone exposure could very well be a driver of sexual orientation later in life. Now, this is relatively early in the pursuit of this topic, and more research needs to be done, but I think this is a very convincing result that neonatal hormones are a place to be looking for understanding where sexual orientation comes from. Thank you very much.